Hello, everyone. My name is Naomi, and I'm an intern in the technology lab for New York Life Insurance. And I'm also a master's student in Northeastern University, Boston. So we're going to talk about serverless GraphQL on AWS Lambda today. So the serverless framework, so I'll start from the beginning. Since the introduction of AWS Lambda in 2014, it quickly gained a lot of popularity because of its serverless architecture, and the developers could just upload their code and they don't have to worry about managing the servers. It was a pay-as-you paper execution model, and it was easier for the startups and new businesses. It brought down the operational costs a lot. So it kind of is a very sorry about that. So Lambda is an event-driven serverless computing platform which eliminates the need of managing the servers, basically. So it was a very good technology, and then as the company started using it, they realized it was very easy for creating simple functions or maybe like a few lines of code. But as you develop microservices, like a lot of functions, if you have, suppose, 100 Lambda functions, it became really difficult to manage it. So some of the challenges which were faced by a lot of companies was the deployment of Lambda functions. So you go to the Amazon console and you upload a zip file there, and then you basically configure the events on which it is supposed to run, checking the logs, version control. So these are also the challenges we faced in our company. So before we joined, the developers were writing the code and uploading zip files on the AWS console, and it was very difficult for source control, deployment, and all of these things. So we had to find a solution for this, and we found Serverless Framework, which is a very which kind of answers all these challenges. Serverless Framework was started initially in 2016 as the JAWS project, which is JavaScript AWS. So it was started by Amazon, and in 2016, it was renamed to Serverless Framework. Serverless Framework gives you a way to package everything as a service. It lets you deploy a microservice as a project. So I'll show you. It comes as an NPM package, so it's very easy to install. You just have to install NPM serverless globally, and you can just go to any of your projects and I can specify the template here. So serverless supports Microsoft Cloud, AWS, Google, and also IBM Cloud. I'm specifying the templates as AWS Nodejs here. The name of the service can be it creates a boilerplate, so this entire project is basically a microservice. I can write a lot of functions here, hundreds of functions. It is very easy for version control. All the developers in a company can work on it. So if I go to, so this is the project which I just created. Serverless YML is the file where I can configure all my functions. It basically creates all these resources I specify here are converted to a CloudFormation template, and it is provisioned in AWS Cloud or whichever cloud you deploy it in. Handler, this is my function handler. So my entire code of the Lambda function goes here. I can have a number of functions here. This is the basic template. It gives you a lot of flexibility for defining a lot of things. I'll just quickly trigger this function. I'll configure an event, an an API gateway event here. You can also configure HTTP events, S3 events, SNS, DynamoDB streams, Alexa skills, IoT. It gives you a lot of functionalities, which is present in the documentation. This command deploys all my functions present in the YAML file to the Amazon cloud. And it'll also give me an endpoint in the end, which is the HTTP request I just created here. It'll take like a minute. This YAML file is essentially a CloudFormation template. You can specify all the resources your Lambda function needs to access. You can specify the packaging here, the artifacts or the dependencies you want to package with your Lambda. It goes here. You can package every function individually, or you can package it with the entire service. So this is an entire, one YAML file is your entire microservice. It can have like a lot of functions. You can specify roles here. You can create roles and policies on the fly. You can just specify all the, we will show you a YAML file, which is a lot more, which have a lot more things than this. But you can specify the resources here, which your Lambda function needs to access. It can also create VPCs, subnets. It also lets you deploy these functions in different AWS accounts. So if you want to deploy it in a production account or test, you just need to change the command here and provide it. You can specify the stage here, everything. So this is the endpoint I just created, and if I go to my browser and check it, so this gives me the message which I deployed in the function here. It's very easy to use. It's a 2-minute job to just deploy a function. You can also deploy functions individually. You don't have to wait for this entire stack update every time. So it also lets you deploy individual functions, which takes like 2 minutes. So if I change my function, it happens instantly. This is their official website. They have a very extensive documentation present. It's an open source community. It's very active. They release new features every month. It's only 1 year old, but they have a lot of functionalities. It's like for us, it's been working great till now. It also has, so you can even develop plugins for your own needs. If you're using Serverless Framework and you think you need a functionality which is not yet present with the community, they have plugins for it. So you can develop your own plugin and push it to their Git and use it as an NPM plugin. You can even, for testing, so they have a very good logging functionality as well. So if you want to, they have a DynamoDB plugin which lets you create a local version of DynamoDB as well if you're using DynamoDB. So your database will be running locally and you don't have to go to like deploy the function every time on AWS and then test it. So we'll start with GraphQL now. So this is the basic serverless framework we used, and now Sandarsh will continue on the GraphQL part and how we used GraphQL serverless on AWS Lambda.
Thank you so much. So for those of you who don't know, GraphQL provides a query language for your API. It was introduced by Facebook in 2012, and it quickly gained popularity, and people started comparing it with the traditional REST API architecture that everyone was using. Although that is a debate for like another day. I would just like to say that very early on, we decided that we wanted to use GraphQL because we had certain use cases which justified the need for having it in our architecture, in our tech stack. So, and the company's vision was to go serverless and have no servers in place. So serverless framework was really very helpful in that respect, wherein we could deploy entire microservices, have a way to version them and stuff like that. All of the features that Naomi just discussed. So one of the challenges was GraphQL traditionally runs in a server environment and on an API server, and that is something that we were experimenting with, and then we came up with a proof of concept wherein we were trying to run the entire framework on AWS Lambda, and we were able to do it using the serverless framework. Hence the talk today, right? So yeah, some of the features I've just listed them. It was released by Facebook in 2012 to optimize their data fetching mechanism. It's open source. Um, it's the results you get using GraphQL are very predictable. So it responds to the specific queries that you're making to the GraphQL server, essentially. And the front-facing applications are very lightweight. Your network utilization is optimized because you will essentially not fetch anything other than what you need to like kind of render your view, right? So it's a single point API, a single endpoint API. So you just have one endpoint, and then you have a schema that is defined on the GraphQL server or the service, and you release the schema, and anybody can query your endpoint to get the data that they require, right? So this is what it kind of looks like, right? This is a snapshot from their own website. So they have a root object called a hero, and they query for the name and the height, and it returns the name and the height. You could have queried for a lot of stuff, like the films he has acted in and stuff like that, and you'll get exactly what you query for. So this is just a quick lightning introduction of for those of you who are like not very aware of what GraphQL does. So I'll do just one more demo, and then we'll wrap this up. This is the architecture skeleton which we have prepared today. It's like the computer that you see is our Postman client, and using the serverless framework, we'll be kind of deploying this area right here, where the API gateway and the Lambda will be deployed automatically, like you just saw. We will be including the GraphQL library in the packaging, like Naomi just discussed. And excuse me, I already have a Amazon DynamoDB instance running, but you can GraphQL gives you the flexibility of resolving the data in any way possible. So, like you'll soon see. So yeah. Let's just go here. Right. So as we just discussed, this is a slightly more sophisticated YAML file where, although there's just one function that's defined, which is get user, you're defining, IAM roles here, and attaching policies to those IAM roles. So right now I'm kind of allowing it to get certain items, query and scan my DynamoDB, which is this resource. I'm allowing it to create logs and log streams, which is helpful in debugging. Otherwise it won't create any logs, my function execution. And I need to allow S3 put object in all of my functions because serverless framework automatically pushes your CloudFormation stack to S3 so that you don't lose it, even if you lose the project somehow. Yeah, so you can define environment variables like we previously discussed. So I'm just defining one, which is the user table, p_v1_user, and you can see that I am referencing it in the code right here. So this will automatically be deployed as an environment variable. If you start using this framework in the way it was meant to be, I think it will eliminate the need for you to ever open AWS's console again. Like you can literally do everything that you need, even fetching logs right into the terminal. Um, right. So coming to just the basics of GraphQL and what it does, you define schemas. So right now, my schema is defined something like this. I have a root object called the user, and then I have uh, two nodes for the root user, which is user info, and some additional info that we would like to fetch. I like this stuff is coming from DynamoDB. This stuff is just hard coded in the code right now. So you can like resolve anything here. You can call other Lambda functions. You can resolve from Dynamo. You can resolve from a relational database. So GraphQL is very flexible that way. Um, so right, and so the schemas are defined in such a way. You have a resolver inside the schema. So you define it as a user info schema, which is the type. And you have user ID, which is a string user item ID. I think all this stuff is self-explanatory. Yep. So, and this is the stuff that's hard-coded. I'm just returning whatever I hard-coded, the JSON object here. So let's just run this. So if I just deploy this again, you'll be, sorry. If I just, so after deploying this, you see that the packet size has drastically increased. It's like 5.5 MB, whereas in the previous one, it was just 410 bytes. And it's just deploying the template right now. I had deployed it earlier as well, but just to showcase what the framework and GraphQL can do together. And soon we'll have a post endpoint because the method that I'm defining here is post. So GraphQL essentially gives you just one post endpoint. Oh, well, two endpoints, but for all intents and purposes. You paste this here. Oh, it doesn't run. Right. So, and suppose you're like a front-end engineer who just needs just a bit of the data and not everything that's included here inside this. You can simply just remove this entire thing, and your query will still work. You just get what you requested for. You will like not have to request the entire object over the network, and then if there are references inside the object, you make another call. If you're designing on GraphQL properly, all your views will require just one API call to the GraphQL server, and your entire view can be populated by that. So with this, we'll like to conclude our lightning talk. Thank you so much, and have a nice evening.